Welcome, welcome. So this is video 2. Today we are describing and graphing quantitative data. So this corresponds with section 1.2 in your textbook, The Practice of Statistics, 5th edition. If you would like to go there and follow along, you can always do so. Also, there are more examples and notes for you in that section of your textbook. Let's review real quick. We've talked about numerical data being referred to as quantitative data, and we said the N in quantitative matches the N in numerical, and that's a way we can distinguish quantitative from qualitative. We also said be careful, not all variables that are numbers are quantitative. And for that, we talked about your grade in school. The fact that you're in 12th grade does not mean that that is a numerical variable. But we talked about examples of numerical variables, test scores, height, length of time, age, distance, and many more. So we're going to look at some today, but specifically, we're going to look at how to graph them. The first type of numerical and quantitative graph is called a dot plot. Each dot represents one data value, and we stack dots evenly on top of each other to observe the shape of the distribution. The one thing about dot plots is they're good for smaller sets of data. If I have a large set of data, it is very difficult to make a meaningful dot plot by hand. So let's take a look and actually make one of these dot plots. Actually, we made one the first day of school, but let's take a look at another example. So if you're writing this down, which you all need to be, you need to write down this data set of numbers. This data set of numbers says the school library collects data on the number of books students check out each month. They take a random sample of 25 students and record the number of books each student checked out last month. Make a dot plot to display the library's findings. So, I've set up our number line down here. We're going to be using this, We're going to be using this section down here to graph. So for dot plots, you are going to put literally a dot above the number on the number line. So my number line says number of books. Each of these numbers represents the number of books each student checked out last month. So we'll start with number 1. So one student checked out 1 book, so I'll do a dot above where 1 would be. One student checked out 7 books, 6 books, 4 books, 8 books, 15 books, 6, 7, 9, 13 books, 14 books, 10 books, 5 books, 10, 10, 11, 9, 15, 2, 12, 6, 8, 24, 17. Okie doke. So we just made our dot plot. We put dots above the number of books. If I had multiple ones, like for 10, I just stacked those dots on top of each other. So this would be our dot plot, and this would be a complete answer. Everything you see right here is a complete answer for making a dot plot to display this data. But dot plots are kind of hard because if I have to keep going with dots, that's going to get kind of annoying. I don't want to keep doing dot after dot after dot. So we also frequently make histograms. This is our second type of numerical graph. We're only going to talk about 2 today, so this is the second type. So for histograms, we use bars to display the percent of observations. Notice it's the percent that we display. We group data into classes or equal width groups. We are going to be really practicing making these classes and these equal width groups. So if you look at my axis down here, it does not have every single test score. It has ranges or classes of those test scores. So here are my steps for making a histogram. Make sure you write down these steps. The first is to divide data into equal classes. Then we find the relative frequency or the percent of observations in that width or in that class. Then we draw bars for each class, and our bars touch. That's different than bar graphs. That's a big distinguishing feature between bar graphs and histograms. So let's make one. So this is the same data that we had before. Here are the library findings, and we're going to make a histogram to display this data. So in order to make a histogram, we need to make a relative frequency table, which means we need to divide our data into classes to find percents or the relative frequency before we can graph it. So I did the first one for us. The first one says the class goes from 0 to 4. If I want my axis to go 0, 5, 10, 15, 20 on the bottom, I'm going to look at the left side of these ranges. The left side of these ranges, this 0, 5, 10, 15, 20, is what my tick marks are going to be on my x-axis. So in between 0 and 4, there are 3 values that the library found that are in that range: 1, 2, and 4. That gave me a frequency of 3. Well, there are 25 numbers listed here, so 3 out of 25 gives me a relative frequency of 12. So I would keep going, and I would say, well, between 5 and 9, I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 11 out of 25 gives me 44%. And I would keep going with this until my table was all filled in. So you can see I have filled in my relative frequency table over here. You will be given this on many tests and quizzes in my class. However, on the IA and on AP exams, this will not be given. So you need to make sure that you know how to fill this in even when you are not prompted to do so. Remember, in my class, on some quizzes, it will give you that table and you get to fill in the table. It will give you the outline. But on the AP exam and IAs, that will not be provided. So we have to get comfortable with making that on our own, even when we are not prompted to do so. So now that I have my percents, I'm going to be making a graph with this column over here. This is the column I care about. So I set up my graph. I have my title, Do Students Use the Library? I made that up. The percent of students is my y-axis. The number of books is my x-axis. So I'm going to draw bars that match those percents. So the bar from 0 to 4 is going to go up to 12%. The bar from 5 to 9 is going to go up to 44%. So I'm doing this with my finger, so you should probably be doing it much neater with your pen and pencil. The bar from 10 to 14 is going to go up to 28%. The bar from 15 to 19 is 12 again. And then I have a bar with a height of 4. So this would be my distribution. Mine is rather messy, but yours, hopefully, the bars are much prettier and much nicer, but the data looks the same. You see this general curve and this general flow, the shape of the data is the same. So key point number 1, we can use box plots and histograms to display distributions of numerical data. We're going to see this word distribution a lot. Distribution just means data set. So dot plots are good, they're more exact, but they're not as good for larger data sets. So histograms are what we tend to make, or box plots, which is what we're going to make next class. Well, once I have a distribution, I need to describe it. So if I have to describe a distribution or a graph, if that's the prompt given to me, the first thing I talk about is shape. What is the shape of the graph? Is it skewed one way or the other? How many peaks does it have? We are going to look at some examples of this on the next page. So hang tight, examples for shape are coming on the next slide. Then we want to talk about outliers. Are there any points or bars clearly away from the overall pattern? Are there any numbers that are just way far away from everything else that would be considered an outlier? We are going to have a rule to come regarding an outlier. So that says rule to come because there will be one in the next few days. For center, we want to talk about the mean and the median. We want to talk about both of those things because as we're going to learn, it really matters the difference between the mean and the median. Their relationship tells us a lot. So center is the mean and the median. The mean we find by adding up all the numbers and dividing by the number we added. The median is the midpoint, or if I lined all of my numbers up in increasing order, the median would be the middle number. The last thing I want to talk about is the spread. For spread, we're going to focus on the range, which is my highest value, subtract my lowest value. And that's going to tell me how spread out are my data values. Are they close together? Are they far apart? These are the 4 things we have to talk about, and we call them our SOCS, or SOCS. If you see me say that, or if you're ever asked to describe a distribution, don't forget your SOCS. Here's some examples for shape, like I mentioned we'd look at. Make sure you get all of these down. You want to have examples for all of these shapes because all of these are important. So make sure you get all of these down. The first one is unimodal and symmetric. That means it has one peak. Uni means one peak, and symmetric meaning it looks the same on both sides. Or if I were to draw a little line going down the middle, it looks like it mirrors itself. The next one we have is uniform. Think uniform. Everything is the same height or about the same height. So uniform is also going to be symmetric because if I drew a little line down the middle, it'd mirror itself on both sides. The next one we have is called bimodal. Bi means 2 peaks, like a bicycle has 2 wheels. So bimodal means there's 2 distinct peaks in your graph, and it's symmetric because if I drew a line down the middle, it'd mirror itself on both sides. With bimodal, it's really going to be a bimodal shape, not just a little dip in the data. So bimodal is the other type of graph that we can have besides unimodal. We don't really say anything past unimodal and bimodal, so don't say like trimodal if it has 3 peaks. That's nothing, so don't say that. Unimodal and skewed to the right means that the right tail goes further than the left tail. If something is skewed to the right, that means it goes up towards the left and then way out to the right. Skewed to the left means it goes far out on the left and then it goes over and gets more condensed to the right. So whichever way the tail is longer, that's the way it's skewed. So skewed left is longer to the left, skewed right is longer to the right. And I'll erase those marks so you can see the original graphs clear. So to put it all together, if I'm asked to describe the distribution of library books, so this is the example we've been working on the whole video. Once I make my histogram or my box plot, I can go through my SOCS, or my shape, outlier, center, spread. You can write it just like this every time. This is what a complete answer should look like. So this whole box represents a perfect answer, meaning it talks about all the pieces that it needs to talk about. First, it talks about shape. The shape of this data is unimodal and skewed to the right, because if you draw a little imaginary curve, you see that there's one peak, and then my data goes out to the right. So the shape is unimodal, one peak, skewed to the right because the right tail is longer. For outliers, there was that student who checked out 24 books, and that was a pretty far outlier. If we look back at the dot plot, 24 was very far from everything else, so 24 is probably an outlier. The mean is 9.5, and the median is 9. The spread is 23 books. That is the range because my books go from 1 book to 24 books, which gives me a range of 23 books. So key point number 2, when describing a distribution, we need to talk about the shape, outliers, center, and spread. That is the only way to have a complete description. So if the question asks you to describe a distribution, you need to talk about all 4 of these. Do not forget that. That is a huge place where students tend to struggle. So here are your tips for graphing to get full credit. The first one is you must have a title. You need to have a title. Remember the titles. Think about Denzel Washington. You have to have a title on your graph. You need to label both of the axes. Your y-axis is going to be percents, and your x is going to be whatever variable it is that you are measuring. So your x is the variable that you're measuring. Your bars should be equal width and straight edges the best you can. Always include your SOCS. You need context with that. Don't just say the range is 23. Say the range is 23 books. We'll get a lot more practice with that, but AP really wants context. When in doubt, give more. Be as thorough and as descriptive as you can. This is the best way to ensure that you get the most credit. So that's a wrap. We can use dot plots and histograms to display quantitative data, and we use SOCS to describe a distribution. Remember, this is section 1.2 in your textbook, and you can go back there if you would like to see more examples. See you later.